At any moment, that bell is going to ring and it's going to be loud, so I'm going to get cooking here. So we're going to look at this last problem here. This 2x squared plus 11 equals negative 37. So first things first, we want 2x squared by itself. So we're going to move this 11 over here, and that's going to give us negative 48 is equal to 2x squared. The next step, divide by 2. Remember, you want to get the x squared by itself. So you got to first add or subtract and then divide. So we get x squared is equal to negative 24. Looks pretty harmless, right? And now we are going to square root everything. So we're going to get x is equal to plus and minus. Now, let's look at this negative 24 here. So let's do this off to the side. So that's going to be the same as negative 1 times 24. So I'm going to get an I out of this from the negative 21. The 24 I can refactor into 4, square root of 4, and the square root of 6. Well, square root of 4 is going to become 2. So we're going to have 2i square root of 6. Right? So we're going to have plus and minus, and then I'm going to rewrite this as 2 square root of 6i. Put that on the back end there. And yeah, that's how these work. Right? Usually tack that I on. That's one of the last things you put in there. And you're in good shape. All right, so again, you're rearranging things, you're doing things that we've done all along just to get that variable by itself, and so that we can get ourselves to a point where we can factor out that negative 1, and then solve the positive part normally, and then that negative 1, when you take the square root, it becomes I. Okay, so difficult concept, definitely not easy to explain why you need to be able to do this, but it does definitely have some modern applications, and it's for anybody who does wind up going into any kind of a STEM-related field. They may or may not, run into this with some of the calculations they have to deal with. So it's interesting stuff. All right, so thanks, guys, and we'll see you.